Let's welcome Kishor Radhakrishnan to the stage.
Hi. Good afternoon, everyone. I hope everyone had a nice lunch. So today I am excited to talk about the story of how we are building a resilient data and AML platform in Air India Limited. So I am myself Kishor. I'm a data platform architect in Air India Limited. So just start our session. So I think we don't need an introduction about Air India. Most of the people know about Air India for a long time. So we are a 90 years old company. But I want to say a different story about Air India. So our CEO used to address, we are working like a startup. So as you all know, 2 years back, government transferred the ownership to Tata Group, and we are building or we are undergoing a massive digital transformation. So in that digital transformation, data is taking the center stage. So as you everyone know, as like any company, as an airline, we are generating tons of data on day-to-day basis. So whether it's flight operation data or booking data, customer behavior, revenue optimization, all those kind of data is getting generated within an airline. But before we didn't had a proper data or AML platform, so we started building from the scratch so that we can use the enormous data and generate value out of it. So for that purpose, we started building a data lakehouse platform. So this is a simple description of our data and AML platform. So it is divided into 3 sections. I can start with the data sources. As I said, the airlines are generating a lot of data from different sources, starting from the airline cockpit to the booking centers or the website, our apps and all. Every day, data is getting generated a lot. So we need to ingest data from different sources, whether it is from a file transfer or databases, different APIs, or the public APIs, including the IATA data and all, and then the flight operation, flight status. So all the data we need to integrate into a common data lakehouse platform, so it can be used to generate value out of that. So first, we set up the ingestion framework. So it involved the real-time ingestion using Event Hub, and the batch injection we were using Data Factory, and the logic app for ad hoc and other event-driven ingestions. And we are bringing all those data to an Azure Data Lake Gen 2 storage. So we were following a Medallion architecture. So the data will be initially sourced to a staging bronze layer. It will be the raw data without any transformation and all. Then we will apply the transformations and convert it into a silver layer. And then we will move it into a gold layer, which will be having the business rules applied, aggregated, and the data which is ready to be consumed. So from the gold layer, we will start our saving stages. So we will be having operational data stores within Postgre, and there is a Cosmos DB as well. These data stores will serve to our mobile app, website and all. So when you check the flight status or your baggage tracking, all this information, we are feeding the data through these data stores. Then comes our AML serving infrastructure. So we are using Databricks platform for most of the compute, Spark compute and the machine learning workloads. So in the serve area, we have the Databricks machine learning framework. So we are using a model registry which will be having the open source models pre-built available provided by Databricks, and we will train our own models and publish to the Databricks Unity catalog governed features model registry. And we have a feature store as well, where we will bring our data from the gold layer. We will do more rules to use it in the machine learning frameworks, and we will push to that feature store. So as I said, like, we are using Databricks Unity catalog for our data governance. So all the data will be controlled through ACLs and RBAC rule. So we can monitor who is accessing the data. We can control in a granular way how the data is moving across the lakehouse. And our compute will be Spark compute. So most of the computation is happening through Python, Scala, or SQL code. And it will be serverless or job clusters or SQL endpoints we are using. So this is a simple description, I can say. But when we started with this, we started facing a lot of challenges. because it is not easy to maintain such a massive scale of data lakehouse platform. Because most of the time, we were spending to set up the platform itself, how to ensure the security, how to maintain the compliance, how to manage or scale the infrastructure in a better way. So then we adopted the DataOps practice. So unlike the traditional just DevOps practices, the data infrastructure require its own different setup actually. So that's why we are using the DataOps framework for automating all these tasks. So the data engineers and data scientists can focus on delivering the business value. So what we did is like all the data ingestion or the infrastructure part, we use Terraform standardized modules. So all the security best practices, all the infrastructure standards, everything will be developed through Terraform standardized modules, and it will be published in a Terraform registry. So whenever we need a data infrastructure like a new data container, or we need a data factory service or data bricks, the data engineers can quickly provision it through the standardized Terraform modules. They don't need to worry about if whether the security practices is implemented or we are following the better network architecture and all. So we fix it that. Then the data ingestion, we developed a framework. So every time someone don't need to go and develop the code again. So the ingestion framework, you can define different sources, and you can just define the business rules within that, and the framework will itself load the data to the different layers. So it is like an easy plug and play setup. So data engineers don't need to spend much time on that. So and after that, so we bought a lot of data to the lakehouse, but it should be easily accessible, or it should be found pretty easily and used within different business use cases, right? So we introduced data discovery and access control. As I said, like we were using a catalog, Databricks Unity catalog. So based on that, we can actually pretty quickly search the data, or even you can use the natural language to chat with the data as well. So suppose if a pricing manager or someone want to know which route is performing better or which route is not optimized properly, he can just ask the question in a natural language. So the framework will check it, and it will generate the SQL behind, and it will give the output to the user. Then after that, we set up these practices. So as I said, right, so the framework itself will generate the code as well. You don't need to go and recreate the code every time. So after that, the change management process as well. So we have a standardized change management process. All this will be happening through the framework. So there will be Azure DevOps pipelines. So people can create or change their own rule sets. They can publish a pull request. All the approvals, review, everything is happening through the DevOps pipelines. So we are ready with our data. The data started flowing. So we started serving the data through the Power BI and Tableau dashboards. The dashboards are live and running. Our CFO, CEO, everyone can access the data. But then we face with unique challenges. Like as an airline, we are getting a lot of sensitive data. Like we are bringing the passport data, or we are bringing the other data, or social security numbers, or the credit card numbers and all. So initially, as we were undergoing a transformation, in all the hurry-burries, we bought a lot of data, but we didn't classify it properly. So there were a lot of data exposed to a lot of users. So we need to address that challenge to ensure how we can successfully mask or introduce rule set to hide this sensitive data, or it will be accessible to only the people who are supposed to access that data. And along with that, as I said, like we didn't adopted much open source tools. We were using data lake, Databricks, or data factory kind of tools. The cloud costs were also in a rising state. So it is like all the Spark workloads, we were not optimized properly. People were just running the workloads. So it will be bringing a lot of cloud cost. So these two challenges also we need to address. So for that, we created our own custom observability and data masking setup. So in the initial days, Databricks didn't provide a setup to mask or identify the personally identified data. So we actually tried Presidio. It is a named entity recognition machine learning library. So using Presidio, we scanned the whole data lakehouse, and we identified and tagged all the columns having the sensitive data. So it will scan the whole data. It will identify where a phone number is coming, or where a person first name or last name or Aadhaar number is coming, and it will tag those data in the columns. So after identifying the PII data, we build custom dashboards to identify who is accessing, or there will be a proper audit happening who have access to those data. And if anyone is not need to access that data, we set up custom rule sets, like only data engineers can see that data, or only the finance team can see the finance related data. And we applied, or we wrote our own rules to hide those data. So through that method, we introduced a proper PIA identification, tagging, and governance practice. The next challenge we were facing is like the rising cloud cost. So Azure itself, you may be wondering, like Azure itself will provide like how much cost is happening to each service, which is, if any anomaly is happening, the Azure itself was providing such services. But that was not enough for us. Because as I said, like thousands of pipelines were running daily. Many people were running SQL queries. Their own notebooks were running. We need to have a granular view on how each workflows or data pipelines are costing. So we set up our own customized observability dashboards. So if you go to that dashboard, you can see how much your query is costing. So the Databricks pricing model is like that. For the hours of compute, they are charging. But that was not enough for us. We need to know how much is SQL or how much each notebook is costing. So we used the Databricks REST APIs, and we built our own machine learning libraries to identify which job is costing more. So based on that, we can do the performance optimization. So along with that, we were scrapping all the Spark logs, and we built a recommendation engine. So it will show if any inefficiency queries are there, or if there is any data sets which are exposed without proper filters and all, the recommendation engine will provide the recommendations. So the data engineers or data scientists can log into the dashboard. They can, there will be a natural language question feature as well. So they can ask how much cost is for our workload, and it will generate the recommendation as well. So based on that, we can optimize a lot of cost as well. So we can efficiently run our data lakehouse platform. So now you may be wondering, like, we didn't use any open source platform, which will be better for improving the to improve the cloud cost and all. So that is our next step. So we are planning a sequel where we want to build our own open source based data platform. So for that, we are using Apache Spark, and the Spark will be hosted in Kubernetes clusters, and we will be using MLflow and Kubeflow for our machine learning libraries as well. So that will be a most interesting phase of us. So we just started with our development workloads to run in a open source Spark Kubernetes clusters. So we don't need to depend on the PaaS offerings. So you may be thinking like, how difficult it will be. Like, we already built everything in Databricks, and the conversion will be a difficult process. But Databricks, we were using Delta tables. It's already open source. So we can use the tables we created in Databricks outside Databricks as well. So we can connect in the open source Spark as well, and we can use that tables. And all our machine learning model registry is everything already in MLflow. So that also we can use outside in open source thing as well. So maybe in the further DevOps meetups, I will be having more interesting stories to tell about how we are transforming from a PaaS, highly not that optimized data warehouse to an open source, custom built warehouse. So that is about the story. We just started with a lakehouse and how we will be transforming. So thank you everyone, and thanks DevOps Kerala team to give me an opportunity to talk here.
Any questions?
Yeah, hi Kishor. Thanks for the very interesting discussion. So you mentioned you are moving away from Databricks to an open source based Spark
Yeah, so
platform.
like not entirely moving away,
But you plan to do
at
that.
least our lower environment workloads.
Okay. What's the primary reason for this? Is it because of the Databricks license or is it because...
It is obviously the Databricks cost. So when we are running the Databricks, we need to pay the compute cost and there will be a DBU cost for the Databricks. So actually we are getting a huge bill on the Databricks. So we are trying the open source. Anyway, we can run it in Spark on our customized setup, right? So that is the main reason.
And that will continue to be in the cloud or do you plan to move it?
It will be still in cloud. We will be using AKS only. Okay. But still we can save the Databricks DBU cost and we will be having better control on our workloads.
And what about the ML ops and all that? Do you plan to use Azure's managed service for
Currently
that,
we
or-
are using Databricks,
Okay.
but we need to plan open source on that as well.
But it will be open source, not Azure managed.
It will be, the compute will be still in Azure Kubernetes service,
Okay.
but the applications, it will be open source.
Okay. All right.
Currently, everything is in Databricks, right? So it is like, the control is very limited actually.
All right. And when did your cloud journey start? In Airline?
It is actually maybe 1.5 years back.
Okay.
Okay, so Tata Group acquired Air India in 2022 end, and we set up a tech and digital center in Kochi somewhere around the starting of 2023.
Is the data warehouse modernization complete? It's already
I can't
complete in
say
Azure?
it's complete because it's an ongoing journey, right?
Okay.
Because we are ingesting a lot of data and we are now integrating two airlines together. Air Vistara is also merging with Air India. So a lot of data transformation happening there as well. They were following an AWS infrastructure. We are integrating that back to Azure Cloud.
So in this end target state that you're visualizing, do you think it's 50% complete, 80% complete? What state are you in?
I can say like it's almost 80% completed. Because the data lakehouse is actually generating result.
All right.
Yeah, a lot of area we are using. So if you log into our website, there will be a chatbot. So you can answer the chatbot will answer the customer queries and all.
Yeah.
There also the data will be fed from our data lakehouse.
You mentioned you are moving away from AWS to Azure, some of the
It's
workloads?
not like
Because of
we are
Vistara?
moving, like one airline is merging with ours. So
Okay.
there they are using AWS. So we are transforming that data to the Azure data lakehouse.
You are completely on Azure.
Yeah, we are completely on Azure.
Okay. All right. Thanks.
Yeah. Any other question?
So how much is the data you're generating per day, and how much data size is there in your data lake?
I can say our data lakehouse or the storage size is more than 120 TB currently, and it is growing as well.
Yeah.
The amount of data generated, I can't give an exact
Per day
figure.
basis, I mean, just want to understand, that's it.
That maybe close to 1 to 2 TB data is coming.
Okay,
Yeah.
okay.
But we are following an archival process and all. Again, the data will be in the actual storage. It will be limited actually.
Okay. And another question is like, you are using cloud currently, right? And the cost is high. So are you planning to move to on-prem in future?
That
Because
I'm not
I'm reading a lot of reports saying that people are moving back to moving from cloud to on-prem because of the
Yeah,
cost.
that is correct actually. Many
Yeah.
people are moving to their own private cloud setup. But our journey is little different. We decommissioned all the on-premise setup just 1 year back only. So we are just new to cloud.
Okay.
So I don't know what our tech leaders will think if a move back is possible now.
Yeah.
But personally, I prefer like to get better control. Actually, we can maintain it within our own data centers.
Yeah.
Yeah. So previously also I worked in Azure Cloud itself. I worked for another shipping company. That time also this transformation is happening. They moved to cloud long back. They are now thinking like some application can move back to on-prem.
Okay. Thank you.
Thank you. Anything else?
Thank you, Kishor, for the amazing
Yeah.
session. Now
Yeah.
let's welcome Govind to hand over a token of appreciation.